So if I look at these two graphs and I want to compare the average rate of change, what can you tell me about the first one? It's a linear function, but how about their average rate of change?
Constant.
It's going to be constant, right? So the average rate of change for this one is going to be constant. And the points are all on a straight line, right? How about for the second graph? Is it constant? Will the AROC increase? Yes, right? Because if you look at this, your run is going to still be the same, right? Your run is going to be 10 for all of them, but your rise, yeah? So we're going to say that the AROC is increasing. Points do not or are not on the straight line. Okay, so average rate of change is constant, they're going to be on a straight line. Average rate of change is not constant, it is not going to be a straight line. Okay? So the table below shows the change in height of a tomato plant from germination until the tomato ripens. Determine when the rate of change in the height is 0, constant, or changing. So it's asking us for the rate of change. Okay, so to find the rate of change, I have to do y2 minus y1 over x2 minus x1. I'm not going to write it down, but you know that we're doing 5 minus 0 over 2 minus 0. Okay? I don't have room for all of it, so I'll just write the answer. So we see that the rate of change is not constant. So if I want to determine when the rate of change in the height is 0, when is the rate of 0? Between what week and what week? 16 and 18. Okay, how about when is it constant? So we see so if you look at the average rate of change, the only time that it's constant is the first two, right? So that's between week 0 and week 4, okay? And then when is it changing? And that would be from week 4 to 16. When is the change of rate of change in height is the greatest? Week 6 to 8, right? So right here, right? That's the greatest, right? Because that's the one that gave me 10. Yeah? That means in these 2 weeks, it grew by 10 centimeters versus the other ones, it grew by 5 or 9 or 8.5 centimeter per week, right? But in this week, it was 10 centimeter per week, right? So it would be between week 6 and 8. So if you're going to describe this, what do you say? We're going to say that grows at a constant rate from week 0 to 4. So from 0 to 4 weeks. Then growth rate increase for the next 4 weeks. Then growth rate decreases as the plant reaches maturity. And then after week 16, the plant stops growing, right? So if you look right here, I'm just going to go back to the graph. If I look right here, in the first 4 weeks, you kind of have a straight line, right? And it does make sense that I have a straight line because I have a constant rate of change, right? Now, and then it starts increasing, right? So it's increasing. So now it's kind of more exponential, if you want, graph. And then it plateaus after. at rate 0, we have a plateau. So, if the rate of change is 0, the first difference is going to be, what's the first difference going to be? It's going to be 0, because when you do 90 minus 90, that's going to give you 0, even if you don't divide by this, right? So if the constant rate of 0, then the first difference is going to be 0. And then it's going to be a flat horizontal line on the graph, right? It's going to be a plateau. If your rate of change is constant, that means your first difference are equal. And it's going to be a linear graph, straight line on the graph. It could be going up or going down. If your rate of change is changing, then the first difference are not constant, so they're changing. And you'll have a non-straight line on the graph. Could be anyway. Remember the difference between the average rate of change and the first difference is the first difference you only do y2 minus y1. You don't do over x2 minus x1. Okay? You're only doing y2 minus y1, y2 minus y1, y2 minus y1. When it comes to the average rate of change, you're doing y2 minus y1 over x2 minus x1. Okay?